Hello listener, I will repeat the question first. Question is a single phase full bridge inverter fed from 230 volt DC is connected to load R equal to 10 ohm and L equal to 0.03 Henry. The inverter is operating in 180 degree square wave mode. The RMS value of fundamental component of output voltage is, there are four options given: A 207.10 volt, B 407 volt, C 217 volt, and D 237 volt. So the key thing in the question is that it is a single phase full bridge inverter. So the core concept would be, how does this work? Operation. Fed from 230 volt DC. So the voltage source amount is 230 volt. Let's call it source voltage. Is connected to load R equal to 10 ohm, L equal to 0.03 Henry. The inverter is operating in 180 degree square wave mode. So we have to note down that also. And we have to find out RMS value of the fundamental voltage and not the current. So the first core idea would be to find out how does single phase full bridge converter work, basically the operation. Second is we have to find out output voltage. Waveform. Then once we know the output voltage waveform, then break it into fundamental and harmonics. Using Fourier series. Now after that, we can find out the amplitude of the fundamental, and from amplitude we can find out RMS value. So let me rub the question now. So first thing is, how does this work? So let's look at the circuit diagram. So for full bridge, basically the circuit looks like this. So there is one thyristor like this, another thyristor connected, and this is the gate voltage of those transistors. Then there is anti-parallel diode connected to that. To take care of the current flow change across the inductor. Then other set of thyristors are connected like this with the gate, and then we have another set of anti-parallel diode connected, and the voltage source value is Vs. So since it is a square wave and 180 degree, it means actually there are two phases of operation. In one phase, the current flows like this. Basically, this thyristor and this thyristor are on. So now positive side of Vs is connected to this node. So this becomes plus Vs, and this is negative side is connected to this. So this side is negative, and other phase would be where these two thyristors are turned on. In this case, this side would be connected to plus, you can see, and this side is connected to minus side. So basically, since it is 180 degree, it means duty cycle is 50%, and the waveform looks like this. So this is, both of them are equal, and the amplitude would be plus Vs and this side minus Vs. So, and this waveform is because it is 180 degree square wave. Otherwise there could be another kind of waveform also, like this, steps. Like this, and continued, and then duty cycle could be different as well, but according to the question it is 180 degree and a square wave, so the duty cycle is equal, and amplitude is plus Vs and minus Vs. So this is, both two concepts are hopefully clear now. Now we have to break this square wave with duty cycle of 50% and traversing between plus Vs and minus Vs, and if we convert that into Fourier series, then the fundamental would be 4 times Vs divided by pi into sine of omega t, where omega t is the periodicity of this waveform. And now this is the amplitude of this fundamental. Now RMS value would be 4 Vs divided by pi, and we know that we have to divide it by square root 2. Now here Vs is given as 230 volt, so we can replace Vs by 230 volt divided by pi into root 2, and if we do calculate it, then we will find out the value is 207.10 approximately. So the answer is 207.1, that is A, and this is where I would like to end this demonstration. Hopefully it makes sense to you. Thank you.